I could still remember how horrifying the situation was. I was told to go to higher ground, and there I saw how the wave destroyed the city.
After the tsunami hit Aceh, I helped with creating disaster relief centers. There were shelters and small generators sent by non-profit groups. Small generators were not enough to provide electricity for big areas. It was low at night because of a lack of lighting.
After the disaster, I tried to find my friends and my relatives under what was left. I was so depressed at the sight because there was little progress in finding other survivors. I think about 3 weeks after the disaster, I still could not contact my family to tell them that I was alright. However, all communication was down. There was no way for me to tell them that I was alive.
When a disaster strikes an area, rescue teams fly in from all over to give aid. But devastation to the area's infrastructure greatly slows rescue efforts, costing time that many may not have. By finding ways to quickly repair power failures in communications, we can lessen the effects of a disaster. What if this aid could come from something as simple as the sun? The sun is the greatest source of energy in our solar system. Our current methods of collecting its energy are inefficient, and new methods to harness the sun's power are not enough. What if we could use this energy to bring back power and communications to an area almost immediately? Imagine a constellation of satellites orbiting the Earth. Each satellite acts as a mirror, which reflects sunlight day or night, and can be aimed at any spot on the planet. We can focus between 10 and 20,000 lumens of light, or about as much light as the sun gives off in the daytime, providing light a mile wide. In a disaster, rescue workers would be able to work around the clock. While the first constellation of satellites provides light, imagine a second set of satellites in orbit. These satellites will be able to convert the sun's energy into electricity and beam it to the Earth via laser-focused light beams operating at safe frequencies, or microwave energy. With giant solar collectors, the satellites will collect clean, immediate energy, ready to use at a moment's notice. In an emergency, when the power grid goes out, we will be able to send this electricity to flying airships, which will be able to refocus up to 1 gigawatt of energy to any spot on the surface. That is enough energy to power 1 million homes during a crisis. Portable receptors can be erected on site to receive this energy and plugged into the existing grid. One of the greatest issues in providing relief during a disaster is the lack of communication. Phone towers are knocked down, slowing the ability to coordinate relief efforts. We can use the same airship providing power to act as a communications hub and relay communication service to those that need it. The airships would also be equipped with passive electro-optical, or EO, sensors and active radar, allowing us to quickly scan the debris and locate people trapped in a fraction of the time it would take to find them manually. In the event of a disaster, we must be ready to act in order to save lives. With space-based solar power, we can transmit power to anywhere on the planet, relieving pressure on rescue workers and people experiencing a loss of power. This technology, though rapidly advancing, is still in its infancy and needs the support of global organizations and citizens alike. Space-based solar power is paving the way to an alternative energy future and can be used to the benefit of all.